And what you're saying is that the very categories in which we see the world and interpret our experience and the ideas within which we organize our observations and the facts around us and so on are provided by us, so that the world as conceived by science is partly contributed by external facts, but also partly contributed by categories and ways of seeing things which come from the human observer.
That's right. And an example of that in science, I'll oversimplify, but it's not basically falsified, is this wave-particle business. It's not that there's something, an electron, which is somehow half a wave and half a particle. That would be meaningless. But that there are many experiments which can be described two ways. You can either think of the electron as a wave, or you can think of it as a particle, and both descriptions are in some crazy way true and adequate.
There are alternative ways of describing the same facts, and both descriptions are accurate.
That's right. Philosophers have started talking of equivalent descriptions. There's a term used in philosophy of science.
But now, for a couple of hundred years after Newton, educated Western man thought that what Newton had produced was objective fact, that he had discovered laws which governed the workings of the world and the workings of the universe, and this was just objectively true independently of us, that Newton and other scientists had read these facts off of nature by observing it and looking at it and so on. And these statements which made up science were simply true. Now, there came, didn't there, a period in the development of science, beginning in the late 19th century, when people began to realize that these statements were not entirely true, that this wasn't just a body of objective fact which had been read off from the world. In other words, that science was corrigible, scientific theories could be wrong. And that raises some very profound questions. I mean, if science isn't just an objectively true description of the way things are, what is it? And if we don't get it from observing the world, where do we get it from?
Well, I don't want to say we don't get it from observing the world at all. Obviously, part of this Kantian image is that there is a contribution which is not us, there's something out there, but that also there's a contribution from us. And even Kant, by the way, thought that Newtonian science was indubitable. In fact, he thought we contributed its indubitability. The step beyond Kant is the idea that not only is reality partly mind-dependent, but that there are alternatives, and that the concepts we impose on the world may not be the right ones, and we may have to change them, that there's an interaction between what we contribute and what we find out.
But now, what was it that made people begin to realize that this basic conception of science as objective truth was wrong, that science was corrigible, that science was fallible?
I think it's that the older science turned out to be wrong where no one expected it to be wrong, not in detail, but in the big picture. It's not that we find out that, say, the sun isn't 93 million miles from the Earth, but only 20 million miles from the Earth. That's not going to happen. I mean, sometimes one makes blunders even about things like that, but that's like making a blunder about whether there's a chair in the room. Wholesale skepticism about whether numerical values are right in science would be as unjustified as wholesale skepticism about anything. But where the newer theories don't agree with Newton is not over the approximate truth of the mathematical expressions in Newton's theory. Those are still perfectly good for calculation. It's over the big picture. We've replaced the picture of an absolute space and an absolute time by the picture of a four-dimensional space-time. We've replaced the picture of a Euclidean world by a picture of a world which obeys a geometry Euclid never dreamed of. We've swung back to the picture of the world as having a beginning in time, which is really a shocker. It's not even that things once refuted stay refuted forever.
Yes. So it means really that a whole conception of science has been superseded. Instead of thinking of science as a body of knowledge which is being added to all the time by further scientific work, that whole conception of science has been dispensed with, really, hasn't it? And we now think of it as a set of theories which are themselves constantly being replaced by better theories, by more accurate theories, by richer, more explanatory theories. And even the theories we now have, like those of Einstein and his successors, will probably be replaced in the course of time by other, better theories by scientists yet unknown. Isn't that so?
That's exactly right. In fact, scientists themselves make this prediction. That is, that the main theories of the 20th century, relativity and quantum mechanics, will give way to some other theory which will interpret both of them, and so on forever.
Now, this raises a very fundamental question, namely the question, what is truth? I mean, when we say that this or that scientific statement is true, or this or that scientific theory is true, what in these newly understood circumstances of ours can we mean by truth?
There are still two views, as there have been since Kant. One is this old correspondence view still has its adherents. But I think the view that's coming in more and more is that one cannot make a total separation between what's true and what our standards of assertability are. That the way in which what I call, using the Kantian picture, the mind dependence of truth comes in, is the fact that what's true and what's false is in part a function of what our standards of truth and falsity are.
And that depends on our interests, and which again change over time, of course.
That's right.
I'd like you to say a little more about this question of truth, because this again, I think, is puzzling to the layman. I think that people who are not trained in science or philosophy are apt to think that there are a certain set of facts, and a true statement is a statement that accurately describes those facts. I'd like you to talk a little about some of the difficulties that are actually involved in this.
I think the biggest difficulty in science itself comes from the fact that even within one scientific theory, you often find different accounts can be given of so-called facts. This came in with the special theory of relativity, when it turned out that facts about simultaneity, whether two things happened at the same time, could be described differently by different observers. One could say Boy Scout A fired his starter's pistol before Boy Scout B. The other could say, no, Boy Scout B fired his starter's pistol before Boy Scout A. And if the distance is sufficiently large, so that a light signal can't travel from one to the other without exceeding the speed of light, then it may be both descriptions are correct, both are admissible.
Of course, this leads to, profound conceptual difficulties in understanding some modern scientific theories. And this prompts the thought that a scientific theory can be useful and meaningful and can work, even if nobody really quite understands what it means. And this is the case with quantum mechanics, isn't it? I mean, nobody is really sure what quantum mechanics actually means, and yet it works.
That's right. And again, there I want to say one shouldn't push that too far, because I think we don't want to give up our standards of intelligibility altogether. We want to say quantum mechanics works, and the very fact that it works means that there's something fundamentally right about it. And with respect to its intelligibility, we're willing to say in part that may be that we have the wrong standards of intelligibility, that we have to change our intuitions. But in part, there are real paradoxes in the theory, and I think that more work has to be done to really get a satisfactory resolution of these paradoxes. Things are very ticklish now.
Yes. I think somebody hearing our discussion, and to whom perhaps some of these ideas are new, might find himself thinking, well, if all this is so, how is it that science works? If traditional scientific theories are breaking down, if science is turning out not to be a body of reliable, permanent, firm, objective knowledge, if a significant proportion of every scientific theory is subjective anyway, in the sense that it's contributed by the human mind, by the observer, by the scientist, how is it in these circumstances that we can actually build bridges, fly aeroplanes, make rockets go to the moon, and actually make all this soft, fuzzy, changing, partly subjective body of theory work for us? It must fit the world in some very basic way, in spite of everything that we've been saying.
That's true, but I think the contrast between being subjective and fitting the world isn't altogether right. I'm not saying that scientific knowledge is subjective or that anything goes. I'm saying we're in the difficult position that we often are in life of thinking there is a difference between good and bad reasoning, but we don't have a mechanical rule. In everyday life, we use interest-loaded terms. We wouldn't say that there's a policeman on the corner if we didn't have a whole network of social institutions. Somebody coming from a primitive tribe which didn't have policemen might say there's a man in blue on the corner. But the fact that the notion of a policeman is shaped by our interest doesn't mean that it can't be objectively true that there's a policeman on the corner. Also, I think science works precisely because of this corrigibility in large part, as Professor Poppers pointed out. The difference between science and previous ways of trying to find out truth is in large part that scientists are willing to test their ideas because they don't regard them as infallible. in a way that was known at the beginning, and then in the success of Newtonian science, somewhat forgotten. And we've had to be reminded again of what Bacon knew, that you have to put questions to nature and be willing to change your ideas if they don't work.
In some respects, the traditional opposition between science and religion has, the two parties have crossed places, haven't they? I mean, many religious people now believe they have certain knowledge about the world, that it was created by a God, that he made us in his own image, gave us immortal souls which will survive our death, and so on. Certain very fundamental propositions which they hold with absolute certainty. And it's the scientist who believes that everything is fallible, that the world is a mysterious place, that we'll never get to the end of the mystery of, and so on and so forth. Isn't there something in that?
It may be.